Hey everybody, Adam Savage in my cave, and this is Pillbot, the smallest robot we have ever covered on the channel. It is a robot that swims with 3 motors, a camera, lights, and a radio, and I am going to swallow Pillbot so that together we can take a journey through this. But first, let's head out to their factory and find out how they developed this amazing device and just how it does what it does. Okay. There's so many questions, Alex, I have, but I'm just going to open with a TLDR. What is Pillbot? What is Pillbot?
Pillbot is the world's first virtual endoscope. It is the ability to swallow a robot that will go inside you anywhere, anytime, and actually maneuver around and have a look inside your body.
Now, what kind of, I know that imaging inside the body in medicine, we have so many different modalities for doing it. What specifically about this kind of imaging gives doctors a new way to see inside the body?
Generally, it's hard to look inside. So if they have to look inside, sometimes they have to cut you open to look inside or insert tubes into your body, or they're looking from the outside, right? X-rays and MRIs are really great, but you don't get to actually see. Like a doctor's looking for very specific things on what is the health of the tissue and how the body is responding. Right. You need that real time. They want to look inside. And this is going to allow you to do that. You're going to swallow a robot and take a look inside.
Now, I'm looking at this amazing, amazing progression, and I'm assuming that the end we'll be talking about today is at this end of this stack. But there was never a time when someone was asked to swallow anything this large.
No, but this is where we started. And,
so amazing.
We would swim this around in a pool. We called this one Pillbot. And the objective was to just see, what is the dynamics, right? How well does it fly? How much thrust to weight do you need? You know, what are the dynamics? Are you able to control it? You know, roll, pitch, yaw. So this was just a functional, about the right size and geometry for things, which we thought was great. We're like, hey, this works well in a pool. And then we started going, and this is like Raspberry Pi. This is completely simple off the shelf. Then we started moving down to like custom electronics.
Ooh, Kapton tape.
Yes, and duct tape and all the baling wire that you would expect at this phase. And again, this did pretty well. And we're like, we're on the right track. Then we started getting down to smaller sizes.
Now I'm curious, when you go to smaller size, when you went to smaller sizes, and like this is less than half that, and the newest one is less than half that. Are you guys? I would expect that there would be engineering issues with scaling the fluid dynamics.
Huge, and yes, everything changes. So as that
so nothing you learned here.
It did not transfer. It did not transfer. Everything stopped working all of a sudden. And fluid dynamics and Reynolds number is a real thing, right? So fluid at that small scale becomes really viscous, right? The ratio between inertial and viscous forces, those viscous forces start to dominate. And so you're pushing honey. And so every propeller design and every thruster design and every lumen design didn't work anymore. And we had to go back to the drawing board. And so what you see here is a long series of partial successes and learning and getting better and trying something different. There's 5 or 6 different modalities of thrust and thruster configurations. There's a lot of learning. So you can sort of see how quickly we get to almost that size.
Right.
And then all of a sudden there's all this, because this is really hard fluid dynamics at that low level.
I love this kind of progression so much. Every time I visit a makerspace, I say, I want you to put all the failures on the wall. I mean, because there's so much institutional knowledge of wrong turns here that are just intrinsic to the process of getting to the thing, right?
Yeah, this looks pretty straightforward, but there is so much knowledge and history in order to get to that point.
You know, initially we said, we want to make robots that go inside the body. How cool would that be? And we started thinking, how would you do it? I mean, are they worms? Are they inchworms? Are they tank treads?
And these are some of your first iterations of ideation on this.
Yeah, so late 2018, that was our company, was this notebook. And then James started building physical prototypes. So this was his version of a walking foot. And we were thinking, maybe if we had a bunch of walking feet around the outside, maybe that would work. Then we started thinking, hey, let's go corkscrew geometry.
That I love. That makes me super happy.
And the cool thing of this was pulling itself across our couch. And we're thinking like, it's moving, right? Then we started thinking contra-rotating corkscrew. We were doing like flagellating tails, like all the stuff you would see in industry. We were swallowing blank pills just to see if they'd actually go through our bodies, right?
You're just breaking the system down to each of its component parts and solving those problems one by one.
Trying to, right? Yeah. So this guy that you're holding started tying a bunch of pig intestines in knots. We had just gone to the local market and gotten a bunch of...
So you got a pig intestine stretched and you powered up and...
Yeah.
Wow.
And so that's when Ben, who's on our team, said, you know what, maybe instead of crawling through the whole GI tract, if you just drank some water, you might be able to swim. And so that's when we got into this multi-copter concept. And so we said, okay, well, what flies well? This has been through a fair amount, right? But we basically said, what flies well? Well, quadcopters fly well. And so we started this process where we got ourselves a basic printer, we got some Raspberry Pi hardware, and we made a quadcopter submarine. And that gave us, a lot of degrees of freedom. And then we set about trying to make it smaller. So we got down to Red Bull size. This was the first time we went to custom electronics. Yeah, so we left the Raspberry Pi here, but we kept the Wi-Fi link. We kept this camera. We were using a lot of JB Weld.
I see all the JB Weld and the copper balls.
We tried to go a little bit smaller. This was a difficult fundraising time for the company.
I swear you'll be able to swallow it.
But we started to get down to this scale where we had a stack of PCBs that would plug in.
Yeah.
And this actually was a whole new chapter for the company. People started thinking like, hey, this is kind of elegant. We shot this video in a local bar with our fish tank on the bar with the thing swimming around.
Nice.
And to some pretty sweet techno, I might add. And once we had this, the money started coming in a little bit better. And then we said, let's make it small. So when we got to this scale back in June of 2020, we had a swallowable quadcopter. The problem, though, is earlier we were talking about 3 grams. This thing is more than 5 grams, and it sinks like a stone.
Of course.
So the lithium batteries at that time did not have a C rating that could keep up with the motors. So we were using these huge cells with more energy than we needed, but we were choked for current. So from there, this was also a difficult time. How do we make it buoyant? So we went through this savage cut where we said, take 2 of the motors out, right? And so we had this dual propulsion system that could turn left, right, go forward and backward. No Z, right? No true 3D, but at least we shot a video with it moving around in our stomach.
But that must have been a difficult shift to make. You've invested a ton of time in fitting and engineering 4 motors in there, and then you ask, do we need them all? And you chuck 2. That's amazing.
I felt like we were missing teeth, honestly.
Right.
So from there we said, okay, what do we do? Maybe we compromise. So we started to go to a 3-motor configuration. And this is the first version of what is sort of our modern device.
So that's the Z, and then that is the X and Y.
Right. And so here you just see us being like, okay, how do we pack it tighter? How do we stay neutrally buoyant? Everything up until this one is machined nose cones by James.
Oh, no way!
From solid, polished, clear.
Oh, I'm so sorry.
Every single one of those. And each one of those probably represents 50 bots he built, right? So from there, we went to our first thermoformed shell. And it was a little ratty, but even at that level, we thought, this is a good step forward. And you can see we were doing our radio antennas using copper snail tape and the CNC vinyl cutter.
Oh, I love this. I mean, your average person looks at a Pillbot and thinks, I don't know how that sort of thing gets built. But I love that this single 2 feet of progression shows the entirety.
Totally. So the bots that we put in your body today are part of this generation right here. The thing that I'm really proud of is that you met Kian and Tomas, who are now doing an injection moldable version of that design. Wow. So this guy is 3D printed, but it's 3D printed injection moldable geometry. That thing's flying beautifully, right? So we're actually very close to a workhorse production ready robot that we can actually use as the platform for the company.
So I'm curious about the control aspect of this, because I've done a lot of filming underwater. I know that you can't get radio waves out of water very reliably. How do you guys, I'm assuming, control this with radio?
This is right. This is all wireless.
Is it difficult getting radio waves into the human body successfully?
Extremely difficult.
Oh, wow.
Extremely difficult. And so, our body is effectively a conductive material, right? It's salt water largely, and that will block and attenuate a lot of the normal radio frequencies. Right. So you have to be as low frequency as you can, so you have as lowest attenuation. But picking up that signal is tricky. And so we actually have active tuning. So this robot is always fine-tuning and changing its antenna properties in order to maximize that
Oh,
output.
wow. So the signal is a dynamic thing rather than a static thing it's receiving. It has
to be continually optimized.
And that continual optimization based on where in the body it is, or the type of body, or what that person might have eten their whole life.
Yes, and yes.
Wow, my God, because everyone's going to be a different kind of Faraday cage, won't we?
That's exactly right. That's exactly right.
Can we steer one?
Yeah.
Can we steer one around? I see this beautiful thing. Like as a science communicator, an empty tank of water just begs for something to go in it.
Let's fly a robot.
Okay, let's do it.
All right.
Now, before you toss this in there, can you walk me through all of the little systems that are embedded in this tiny thing?
Indeed. So on the back section is what we call the thrust barrel. And so there's 3 motors in there, and then each motor has a lumen, which basically holds the propeller. So there's a propeller on each of these motors.
Yeah.
These are vibration motors from a cell phone.
Oh, they're super tall.
Super small, and they're super inexpensive for us. We 3D print a propeller, we put those propellers on there, and then they're embedded. So those propellers are embedded inside. Okay. So as you're swallowing it and as it's in the human body, those propellers are nowhere near, can touch you as they're spinning.
Right.
Okay? So that whole back end has these lumens. It has sort of stators because they're directing the flow through the center of gravity. Very specific thruster section in the whole back half of this thing.
Okay.
Right in the middle is the battery. It's a nice lithium-ion battery. It's really punchy. It's got a lot of power, a lot of performance to it. It's great technology. And then on top of that is our entire flex circuit. This is all of the components needed to run a robot, right? It has a field programmable gate array, it has a microcontroller, it has motor drivers, all of the things that are needed. It has a wireless radio. All of that's on one flex circuit that we fold up like origami to get to fit in that tiny little top section of this.
This answers the biggest question I had, because we did this video a few months ago where we used a CAT scanner to look inside some cables.
Yeah.
And we saw the degree of intense micro machining and manufacturing that's going on in there. And I was wondering how possible you could iterate something every 2 weeks with that kind of packing. The flexible circuit board allows you to do that.
That's exactly right.
Amazing.
And stacks in there, and it's super efficient volume-wise, but there's a lot going on in that circuit.
Right, because that circuit's got a camera, it's got lights, it's got a signal processor, it's sending out, or it's got a radio transmitter. All of that's happening in there.
In that little tiny circuit that fits in that little spot.
Let's see it swim. Oh, I get to drop?
It's yours.
Amazing. Oh, hi there. Here we go.
Here you go. I can get you going here.
All right. Okay, so. Is this the smallest swimming robot right now in the world?
This is the smallest medical robot in the world.
Gotcha.
In terms of being able to be something that is safe and going through clinical trials right now. So there's been a lot of work done, again, in universities and even in small labs related to this concept, but no one's been able to try to bring it actually a product to market. And it's pretty important. Like, there are people who suffer stomach issues all day long across the world, and pretty major stomach issues, and they don't have a real easy option except to go into a hospital and have an endoscopy done, right? Where they actually have to stick a hose inside you and do that pretty invasive procedure.
Well, and I would imagine, that endoscopy is still an imperfect solution, and that their whole body of knowledge can be built on what normal stomachs look like by doctors using this technology, because they get to see so much more.
It's going to be quite incredible, that easy access, because normally during your lifetime you might have one endoscopy done at some terrible event in your life. But imagine that you could have this as part of your screening every year. You go to the doctor's office and you take a look at your stomach and you map your stomach health. And you improve things in your diet, and you improve things in kind of your lifestyle, and you're actually improving because you have the access to that data.
Okay, so now, I'm sorry, I'm just noticing about the diving. You're using one of the propellers.
That's right.
And that propeller can change direction for diving or rising.
That's exactly right.
Wow. It's watching the little, it's just the mechanical stuff is really fascinating.
You're quite acrobatic in your piloting there.
Well, that's a nice way to put it. Look at that holding onto the bubble. You were talking about it pushing through honey. I think people
have a hard time understanding just how viscous it gets at these scales. All right, so this is the newest iteration, and you guys, again, you're doing one of these sort of, God, I love how I can read the inside of it. You guys are doing about one of these every couple of weeks.
A different design. So we're a low rate initial production. We'll make about 20 robots a week. But then pretty much every 2 weeks, we have some change in it. We're going to change a thruster, we're going to change a process, and effectively it becomes a new robot.
And so there must be like an ongoing, continuing list of new things you want to try, new aspects you want to experiment with.
That's correct. And some of it are just from us, because we're trying to either improve cost or manufacturing or quality. Sometimes it's from the doctors, and the doctor's like, oh, can you add this or do this a little bit different? Right. And then the team will go and we'll design and we'll build and we'll test a new robot.
Now, I think that a lot of people's first question is, how do you retrieve these? I pictured, in my head, I pictured a little 3D printable lattice you'd park on the side of your toilet bowl with some signal thing in it, and it would just swim over to it. That's my idea.
I'll give you a better one. Don't.
Oh, really? Oh.
Don't. Just flush it away.
Really?
It's single-use disposable. The whole intent is to make it inexpensive. Don't ever go retrieve it. My gosh, why would you do that? For a normal endoscopy, there is so much waste because there's so much material that actually goes in and has to get thrown into landfill.
Oh, really?
Yeah, it's quite environmentally not friendly. This is 3 grams of material. And in every sewage treatment plant, they have a stage of filters. Right? There's things get flushed down the toilet all the time. So this gets picked up in the filter so it doesn't go into the water supply and gets put into landfill.
Amazing.
But it's 3 grams instead of kilograms worth of material out of a normal endoscopy that go into landfill.
3 grams, just for reference, that's 3 pennies.
Yeah, yeah.
In weight.
So it is environmental footprint is spectacular.
Oh, and of course I thought about comparing it to pennies because I'm wondering how many pennies you've seen in people's stomachs.
Yes, we do. Sometimes we look around and we go find things that are in people's stomachs. It's kind of part of the testing we do.
Oh my God. All right. We are getting closer and closer to me being able to swallow one of these. Is that right?
Are you hungry?
Am I going to swallow this one?
Let's do it.
Oh, really? Right now?
Let's do it.
Oh, wow. I thought there was a transition. Okay. Here we go.
Okay.
All right. We're ready for the swallowing.
We're ready for the swallowing. So this is your robot. Get to know it. Okay. Point it at your face. And then you can see yourself here on the screen.
All right. I see up and down. That's amazing, the resolution that you've been able to get there. Wow. All right. How much time do I get? How much camera transmitting time is there on this battery?
If you just did camera only, it's like 45 minutes, an hour. But when you're running motors, it's like 30 minutes, 25 minutes.
Oh, wow. So I gotcha. Okay, cool. Is it time we're really doing this? Okay. Here we go. Taking a swig. I'm putting this in. Uh-huh. Ooh, it got caught going down. Scratch me over here. I think it might be.
And you're in.
I'm in?
You're in.
I swallowed a robot. Yeah. I'm now part of the future. So this is the inside of me.
This is the inside of you. Notice that you sort of start to see some of the tissue of the stomach, right? Mm-hmm, and so what you're looking for is color. You're looking for some of these kind of folds. It's called the rugae. And it sort of specifies how healthy your stomach tissue is.
It looks nice and pink to me.
It is. Pink is good.
Okay, good.
Pink is good. That's actually that's what you want it to look like.
And this is swimming around in here, and it's being picked up on a radio in my pocket.
Yep.
I feel nothing specific. It's not like I can tell something's moving around in there. Are you steering it?
Not yet. I want you to drink one more swig of water.
One more swig of water. Okay, here we go. I want to see if we can see this.
Good. Swig, swig, swig.
Takes a second. Oh.
So notice you kind of have Oh, there you go. We're getting some good stuff down
Yeah,
there.
I watch stuff happen. That's really neat. There are times when you drink like a nice glass of cold water and you can feel the cold moving down.
And you kind of feel it inside, yeah. So if you see over here, these are motor thrusts. So you can kind of see when I'm kind of engaging the motor here.
So then you guys are able to actually go back and take a look at what you've shot and see how you got it.
Everything is recorded. So all that telemetry.
It's all data.
Yeah, it is data because you're trying to optimize what is the best way to get out of this glob now. So you sort of see frames per second. We have the different connected. There's a robot that's connected. The wireless data link is connected. The battery. So this connection here is, you're looking at -40, -50 dB. That's sort of saying how much data is able to kind of come out through the link here. Okay. So there's a lot of engineering data that we're looking at.
No, as you're steering, I'm not feeling anything in my stomach. Is that? Has anybody felt the steering?
No, you don't feel the thing.
Yeah.
We've gone ramming speed, trying to go full speed, and sort of see, Can you feel it? Can you feel it? Nothing.
But that's probably because we don't have the nerve endings in there for like tactile touch.
At all.
Yeah.
Which is why when you get a normal endoscope, it is quite uncomfortable because all of a sudden you're getting experiences you've never had before because they're poking around and it's kind of strangely uncomfortable.
And starting to be able to sort of see some structure of vessels.
That's right. And these are things the doctor's looking for. They're trying to see if there's, if you had some kind of tumor or any kind of sort of anomaly, anything they would sort of see, usually some color discoloration, maybe some bumps or something on the surface. Certainly veins that would be going to it. It is interior surface skin, so you see the veins on the surface when there's bad.
We don't know what that is?
That's normal.
Wow.
That's good. So yeah, that's
wow.
So part of like the stomach has an inlet and an exit. Yeah. And so those inlets and exits are opening and closing, and so you might get sucked into the next area of the whole system, which is your duodenum. So right out of the stomach, the next area of the small bowel is the duodenum.
Now, I'm also, wow, oh my God, this is so fascinating. I'm trying to talk slow so I don't overly disturb it. I feel like this looks like a healthy stomach. It's nice and pink.
It is very pink.
I don't see any pennies.
Nope.
There's no T-pins or needles. People have swallowed the most astonishing things. I'm sure you've come across the craziest things people have put into their bodies. So we think that's the exit.
Yeah, the pylorus.
The pylorus. And this is where all the things that I put into my body eventually go through this. So sometimes it says that was just a little too much foie gras. We're going to have to refund. I wonder how long it'll be till people get tattoos on the inside of their stomach.
I like that. No,
this
seriously.
way. Aside from visual markers about where you are within the physiology, are you looking at ways to externally map where the camera is in the body?
Generally don't need to do that because the doctor just needs to have looked at 100% of the surface in case down here is fine, but maybe up here there's something wrong. Okay. And so ideally, we don't even want the doctor. You're a great pilot and doctors are great pilots, but the robot will fly itself better.
I was wondering about that.
Autonomous control. So the robot will start to spin and will map out the entire surface and will know if it's missed a spot because it will reconstruct the surface in 3 dimensions.
It what? What?
It'll reconstruct the 3-dimensional surface.
That's incredible. I did not realize that was part of its charge.
Yep, and it'll say, oh, I missed a spot over here, and it'll go back and it'll get that.
Oh my goodness.
The other thing it'll do is it'll recognize what's an anomaly. It knows that this is healthy, and it'll say, oh, this weird thing over here, let's say, is not. And then it'll go to that, and it'll like scan, in high resolution, maybe to get a 3-dimensional image if there was an anomaly.
So it has its own signal processor on board to be able to make those decisions?
So AI database on the back end, right? You train it. So you have to train it how to do both of those things. How do you get that 360-degree surface imagery of the stomach? Yeah. And that's what the doctor wants. They actually know what they're looking for. And they know where they are based on those things. So we don't have to. We use an accelerometer on there in order to help maintain and stabilize. But the doctor might be like, oh, what's that little thing? And might want to go like zoom up on it. That's totally normal. That's fine. But let's just say that the robot would know that in advance and would go zero in on that spot, and that's what it wants to do. So it does a lot of analysis and controls based on image.
That's really remarkable. I'm also I'm impressed with how much just general ambient movement there is.
Right?
I mean, obviously I knew these systems were working while I didn't have to do a lot of management of them, but watching how much there is going on.
Your stomach's working, and what it's doing is it's munging around like whatever. It's just it ate a thing, and so it wants to effectively work it and start to dissolve it, right? And so your stomach is going to produce acid that's going to try to soften all the material, so that as it goes through the rest of your GI tract, it's easier to digest and absorb. So the stomach's got a big function, right? It's a big bag, and it's gonna sort of convulse, and it's gonna kind of try to work and break up material, getting ready for the next part of the journey in lives.
So one of the things I loved about the talk I saw you give at the conference we met was your theatricality. And I turned to my friend when you swallowed the Pillbot, and I said, oh, it's just all gonna be pennies in there. And I told you that joke, and you said actually that you had, look at this, we're moving places, we're going places, this is so amazing.
You have a beautiful stomach.
But what you told me was that you've actually swallowed things for the camera to see.
We do that quite often.
That has to have gotten a great response.
Generally, and it always scares someone, because we'll swallow something simple like raisins or pistachio or something, but sometimes we'll make something special. And we'll have like a pill with something written on it, and you got to go find that and be like, oh, that's a cute joke or something like that. So we do have fun in the name of science.
I love this. Is it at all possible, while it's still in my stomach, although clearly trying to get out,
yes,
just to go look at this camera with another camera?
You want to do that?
I totally want to do that.
Another robot. Let's go.
This is the best day ever. I'm aware that the nursery rhyme doesn't end well, but we are sending a second Pillbot to go look for the first Pillbot. This isn't an emergency, it's just something we wanted to try. So here we go. Take a swig first. All right.
Okay.
All right, so this is the second Pillbot, and I haven't seen a sign of the first Pillbot yet.
Would you like to go find it?
Oh my God, I'm steering a robot inside myself. All right, so I'm just gonna turn to the right. Oh. Okay, I see there's a little delay.
Little tiny delay.
Sure. I'm gonna push forward. Let's try going up. I'm just trying to do a pan around.
You are in your stomach.
I don't want to get technical or anything. Oh, there it is! Amazing! We went and found one Pillbot with another. The two are reunited, and it feels so good. That was awesome.
You want me to see if I can get a good... Oh, dude, you're right on it.
Look at that. There's your stator. That's the thruster.
Stator thruster.
Amazing. I got to... that recognizable mechanical devices inside my body. That is just so exciting.
You're surprisingly comfortable with this concept.
I'm a sci-fi fan from the earliest possible age. Yeah, no, absolutely. I'm super comfortable with this. Oh, there's the surface.
Yeah, I don't want to go up there. Wow. That's a good view. Look at that. That's looking at your entire body, stomach cavity now. So this is a
from the exit.
From one side. So I'm on one side of the stomach, kind of looking deep into the other one. So this is hard a little bit because you're up against the tissue, but if you can get that big long view, now I just looked at your entire stomach lining.
So this is where last night a hot dog and a couple of Snapples met their end, and now it's all clean and pink again.
It's all clean and pink. Your stomach will empty in about 4 hours.
Really?
Yeah, it'll be clean and clear in just a few hours. All right, so there's your other Pillbot. It's off to the right. So I'm going to go here, and we're going to back up just a little bit, try to get a little bit of a better
Do you find it's easier if people are upright or supine?
So it depends. If I'm trying to inspect the top of your stomach, lay on your side. Now I can get that whole top because there is an air volume, right? And I can't get above that. But you go on your side, now all of a sudden the top of your stomach, and that's pretty important. There's an area where your esophagus enters the stomach. There's a whole bunch of Barrett's esophagus. There's a bunch of different anomalies that happen there. So if we're looking for that, we would want to go there. Okay, I try to see it. There he is.
Oh, look at that. One of them's already kind of trying to escape.
Yeah.
Wow.
Go over here and take a quick peek. See if we can get up.
I should have written "Eat my dust" on the first Pillbot's backside.
Eat my Pillbot. There you go.
We are
All right, we're going to go forward and we're going to try to go find the pylorus real quick.
All right. You're also benefiting, I would assume, from the massive economies of scale for cameras that are still ongoing.
It's amazing. Like, this is only possible because of cell phone technology.
Right.
Trillions that have been put into that, right? You know, it's pennies for that camera.
Right.
It's pennies for those motors. How much do you think that robot costs that you swallowed?
Oh, $100?
$35 in parts.
$35 is the parts list.
That's the parts list. But that's the idea, is if for $35 in parts, swallow one today, swallow one another one later in the week, and another one next week, no problem.
Right.
Because you want to be able to have quick, easy access. Swallow it from home. Like, we have doctors who drive these from around the world, right?
Of course they can.
Why not?
Right.
So, you know, your doctor or whoever you want to talk to can sit there and drive this while you're here in the office or at your home or anywhere.
This is really thrilling, and I have to pee.
Let's get him to pee. Okay.